The virtual demonstrator tool is an animation tool used for teaching learning process, and this is used to study the basic concepts of computer architecture and organization. The virtual demonstrator tool consists of various modules, namely von Neumann model, slide instruction set addressing, instruction fetch, decode, and execute, stack and subroutine, programming in assembly. This animation shows the internal architecture of the computer. It consists of an input unit, output unit, processing unit, control unit, and memory. And this is showed in this animation. And the size of the memory consists of 2k cross m array of stored bits, and the address are and the data is stored in the respective memory location. And this shows the memory interfaces, processing unit, which consists of ALU, temporary storage registers. Input and output devices are the keyboard, mouse, and output devices are the printer. And control unit, the control unit consists of instruction registers and program counters. Then the module number 2 is slide instruction format. This animation shows the basic not register operation. The source consists of the input data. The ALU performs a not operation, and the results are stored in the destination register, which is highlighted in green in color. The red lines follow the set of steps involved in sequencing this operation. The next instruction is or add operation. Here, the two inputs are taken from source 1 and source 2, and the results are process add operation or AND operation, and the results are stored in the destination. The source registers are highlighted blue in color, and the destination is green in color. The next instruction is add and add immediate operation. The as it is known that the immediate data is taken from the instruction register, and data is taken from the source register, and the results are stored in the destination register. This shows the demo of the load instruction. The address is taken from the program counter and stored in the memory address register, and the data is stored in the subsequent memory location. Store PC relative, this shows animation of store PC relative. The data to be stored is stored in the particular memory location. The next instruction shows the animation of load immediate indirect. So indirect address is given to through the instruction. The next instruction shows the demo of store immediate indirect addressing, and the results are stored inside the subsequent memory location. Load load base plus offset. So the data to be loaded is stored from the base and its offset, and the results are stored in the memory location. Store base plus offset. The data to be stored in the memory is taken from the base register, and offset value is added along with it, stored inside the memory address register, and the results are stored in the destination. Load effective address immediate. So the immediate data is taken from the instruction register, and the results are stored in the destination register files. Load effective address immediate. The next instruction is branch instruction. This is used to branch to the particular memory location, and in this context, the logic registers logic flags, negative flag, zero flag, parity flag is affected, and based on that, the program counter is pointed to the memory location which has to be pointed. The next instruction is jump instruction. From the base address, it will be pointed to the program counter. The module number 3 is instruction processing. This shows animation of fetch, decode, and execute cycle. First, the instruction is fetched from the memory, decode the instruction, and evaluate the effective address where the instruction has to be stored, fetch the operand from the memory, execute the operation, and store the result. So, fetching the operation, decode, and evaluate the address is shown in this animation. The module number 4 is stacks and subroutines. The stack is based on last in first out. We can see the uh, values numbered as 0, 1, 2, and this is pushed onto the stack. Stack is a set of memory temporary memory location. The 0 is the first input and this is first out. Pushing an element onto the stack. Here the stack pointer, the instruction shows push 20. The stack pointer is pointed onto the location which has 20. Then push 5, the stack pointer points on to the location 5. Push 10 pushes the value onto the stack, the memory location 10. The last module is programming in assembly, which shows various visualization program on addition, subtraction, and also count program. The program is given on the right side of the table, and 0, 1, 2, 3 are its memory address. So this is the internal architecture of the processor, which consists of instruction register, program counter, multiplexer, decoder, arithmetic and logic unit, and accumulator. So these are the set of sequence of steps happening inside the processor for subtraction program. The blue lines are indicated by data bus, green lines by address bus, and red line by control bus. And the star indicates the set of steps happening inside the computer, and this shows animations of the count program. Thank you.